Hi, welcome back to the Lead Automation YouTube channel. Today we're going to be talking about something pretty cool, how to maximize your efficiency in your manufacturing facility with automation. So the number one thing that I think automation really provides is the ability to give you more throughput. Throughput is essentially the ability to output more product. And you probably already know that because you're a manufacturer and that's the name of the game, right? How much product can you output? So as we've transitioned through time, through the industrial age, today it is more important to automate than ever. We went from a world where everything was a manual task and it was just a single guy doing a single job, and he didn't do one small thing all day. Maybe he was building a car and he built the car piece by piece by piece, right? And that one guy or a team of guys, right, built this one product. And as we evolved in our manufacturing processes, Henry Ford brought us the assembly line, where it was one person doing one task, and now you have an operator versus a bunch of skilled individuals that are required to do a particular task. That is more and more true every single day, every single year. And as we have processes, for example, maybe it's welding, maybe it's assembly, maybe it's material handling, essentially automation is giving us the ability to do things faster and cheaper, right? So where it may have been one singular individual turned into 10 individuals in an assembly line, now can be converted to 10 robots doing that particular task. Or maybe we can flip it on its head and go back to a singular robot, or maybe 1, 2, 3 robots doing a bunch of different tasks, right? Inside of maybe, let's call it an assembly cell. Now, we can kind of do that same thing whenever we go back to robotics, right? Because those processes that we did in manufacturing and creating an assembly line can be reversed to some degree. Now, the assembly line method is still very, very good for automation and robotics, but especially when a budget is an issue, sometimes it makes sense to bring all those things back into one robot doing more tasks. And let's just go with an example such as welding, right? So maybe you created an assembly line where, let's just take my phone for example, one operator welds this part, then they pass it down to another operator, they weld this part, and then we pass it down to another operator, they weld this part here, we pass it down to another operator, they weld this part here, right? And so the whole reasoning for doing that is to keep that efficiency. Boom, you can go, you can do your weld, you can pass it, right? And so that way you're accustomed to doing the same weld all the time. Maybe you need to do a circular weld, just grab this cup. And so this operator is doing this, weld operator is doing this circular weld, right? And so since they're doing that circular weld all day, every day, they're getting very efficient at it. And maybe it takes a higher skill set to do the round weld versus the straight weld, right? You created that assembly line method to increase your productivity, right? To increase your throughput. Well, now, if you have a robot in place, maybe it doesn't make as much sense to pass that product down, and you see this a lot in robotic welding, where robotic welding has converged to being more cells versus lines. So when you see lines, you see most of them at like OEMs, like Fords and Toyotas, and their BIW lines, right? Or assembly lines where they're assembling the total vehicle, right? Well, for some of these smaller components, it still makes sense to store things on a rack, take it off a rack, process it, and then put it back onto another rack, right? Or take a bunch of child parts, put all the child parts into a fixture, the robot does its welding, take it off, put it onto a rack. That's one area where robotics is definitely increasing throughput and also helping with ROI by not having multiple robots. We can even choose based on what your tolerance for ROI is. Do you want one robot? Do you want 2 robots? Do you want 3 robots, right? The robot is taking more time than if you had 3 robots, but it's a lower investment, right? It's tens of thousands of less dollars that it's going to cost you to utilize the one robot versus the 3. But maybe throughput's huge for you, right? You want to get these products in and out the door as quickly as possible. You have winning more orders through your sales processes. You're grabbing the market. You're growing very, very quickly, and you just need to expand. You need to be able to increase your throughput, right? So now it's taking a third of the time with 3 robots to do the welding of this one particular part, and essentially there wasn't much other investment outside of the robots and the power supplies and whatnot, and you was able to increase your throughput by, 66%. Another thing about automation and throughput is robots are just quicker, especially quicker when it comes to doing the same task 100 times, 1,000 times in a row. You know, a robot is not going to complain. A robot's not going to incur injuries. and it's going to be able to move more quickly when it comes to doing the same task over and over and over again. So when a robot is going from point A to point B and it's doing it in 3 seconds, that's something that's very, very hard on a human's body, and it's something that's very easy for a robot to accomplish. Can add more throughput. And then a secondary thing that you can do is add more robots, right? So where you have one human doing a task, you might be able to afford to put 2 robots in that same position, which now over doubles your amount of throughput in that one particular section. So if you're able to do that throughout the entire process, you've increased your throughput by ×2. And then if you think about your company on a entire company scale, right? If you were able to automate every single process and double your throughput through every single process, you've literally just doubled your business. As long as you have the cells to back it up, now you have the throughput to back it up as well. Now, there's a ton of other advantages to automating, like quality controls. You're gonna have less scrap, which is also gonna help your throughput, which is also gonna help your cost. You're gonna have less injuries, which is gonna help your cost, which is gonna help your throughput, because now your employee's not injured and having to go to the hospital and not be able to be at work today. Which brings me to another point, which is probably the hottest point in our industry right now, and you probably already know this, but people can't find employees, or employees are just not wanting to stick around. And because of that, guess what? If your employee don't show up to work today, your throughput is less. And there's some operations that are just completely dead in the water because they don't have enough operators to operate the line. Or you're having to do crazy inefficient things like this operator operating this station here, and the same operator operating a station 10 feet away, 20 feet away, 30 feet away, and it's having to keep constantly run back and forth. Maybe it's a slower operation, and ergonomically, a human walking 30 feet back and forth all day, every day, is not really a good choice, and also, it's not the most efficient. You're gonna start ending up with issues like quality defects. You're gonna start ending up with more employees quitting because the job's hard. Like, a lot of companies don't understand this. Like, whenever you have people quitting because it's a hard working environment, some people quit jobs. You gotta understand, like, this is really the dull, dirty, and dark, and dangerous jobs that I'm digging into right now, which are less, but they still exist, 101%. Those type of jobs, anything that you can do to make them. And then it goes to automation as well, right? Let's take it back to the automation side of things. If you have a human picking up this, 50-pound product, or let's say go a 100-pound product, right? And you have 2 employees who have to team lift this 100-pound product and set it up on a table, right? Why not have a robot lift that product and set it on the table? 1 robot versus 2 humans. If you're running 7 days a week, 3 shifts a day, the ROI is 101% there. The calculation on that would be roughly $300,000 in an ROI, and that's pretty easy. That's a 1-year ROI at that. So if you have a tolerance to be able to have a 2-year ROI, then that's $600,000 allotted for being able to put a robot in there. And something that's that simple, just pick something up and place it onto a table, is not a $600,000 application. You're looking at that being like maybe a $200,000, $250,000 application, depending on all the other complexities go on within the system. And you can also go use robot, right? I wouldn't go and get a dinosaur robot, but if you get a robot that's 5 years old, it's kind of like a used car. You're still going to get a solid car. It's going to work well for the next 5 to 10 years, and you're not going to really have too many issues. That drops your ROI's time frame by quite a bit just because it's less investment. One of the biggest costs to deploying automation is things like the robots. And another way that you can maximize your efficiencies through automation is to tweak the automation, right? If you already have existing automation on your floor, there's a potential that you can increase that robot speed. First of all, identify where your bottleneck is in the operation, right? Your bottleneck is always the reason why your throughput is not as high as it potentially could be, or your efficiency is not as high as it could potentially be. And see, what is that bottleneck? And is it something that can be increased, right? Is there some type of motor that you can speed up? Or maybe there's other methods that you can implement, such as a buffer station. So what's a buffer station? Buffer station basically gives you the ability to store something in a location for some period of time. Let's go with an elevator buffer station, which is definitely a little bit more of an investment. But you can have a single place buffer station, but I'll just go with the elevator one because I think it's a really good example, and a lot of manufacturing companies should have like elevator type of buffer stations, and really every single manufacturer should almost have it, right? Because no part of a process should stop, and if it does stop, then you shouldn't stop other processes because one other process does stop. So going into what elevator buffer station would be is essentially you have like a product run in, right? It's now completed with its task. So instead of it sitting here and waiting while this other task is getting done over here, it don't just sit there and sit idle. It'll actually raise up. There'll be like conveyor. It's conveyor. It's an elevator, however you want to call it, right? But it indexes up, right? And so it'll index one station up. The next part will roll in. It'll be able to roll in right underneath it. It can elevate it up. Your next part rolls in underneath as well. Boom, elevates up. Next part rolls in, elevates up, and they keep doing that, right? And now you get a stack of these, and then maybe the line in front of it starts to pick back up again, right? And start running that at rate. Maybe it was slow for a period of time. So now front system starts to get at rate. Now it can start dropping off parts from the elevator. So boom, now they can go out and move on to the next section of the operation. And you know, some of these efficiencies may be just like learning some more of the process and whatnot, but maybe this entire line works a 10-hour shift, but the front half of the line only needs to work an 8-hour shift because their process is faster. This is your bottleneck processes within the manufacturing line. So that's another creative way to add efficiency within your automation, and overall it helps you have a better process flow, right? I've seen this process utilized in certain applications such as like automotive glass, and that's something you do have to keep in mind, right? Like how big or small is your product? Like if you have a very large product, then your buffering may not have the same ROI. It definitely won't have this ROI. The smaller it is and the thinner it is, the better chance you have to getting a good ROI, because just put an example like this, you know, if you had, let's go with glass, right? If you have glass that comes in and another piece of glass, like the distance at which these are stored from one another is a couple inches, right? Perfect example is like glass, where it may be big in this direction, but it's like very small in this direction. It's perfect for elevatory buffering. It's perfect for elevatory buffering, but if you had a product that was more taller like this, maybe it doesn't work as well to have elevatory buffering, and maybe it makes sense that you have some type of horizontal. But the good thing about elevatory buffering is that it's vertical, right? So a lot of times your overhead space is wasted dead space anyway, versus like if you go with horizontal buffering, which we've done as well. So like, for example, instead, maybe you have like, I'll go with a glass scenario again. So instead of having elevatory buffering, you have a horizontal buffering. And what happens is basically you have conveyors, right? But whenever you get to here, you have like a conveyor that's able to pick this up, and then it'll sit there and wait until the next part comes in, and then this one will be stacked. And so now you can see they're able to store the product in a much smaller area, especially when it comes to horizontally, right? Like your horizontal space is much more expensive than your vertical space. And I think that automation definitely has much more opportunity to go 3D. Even stuff like glass being as small as it is, I mean, you can even vertical down. I mean, you don't have near as much space down unless you already have like 10-foot tall conveyors for some weird reason. But if you did have like 10-foot tall conveyors, then you could elevatory down versus elevatoring up. And it's something to keep in mind. But there's a ton of different sources of automation that can help improve your processes and your efficiencies. As an automation company and looking at like a manufacturing company and trying to provide them value and trying to provide them ROIs and make sure that the decisions they're making are intelligent decisions for their manufacturing company, there are some things that kind of make sense, especially whenever it comes to like meeting customer demands on the manufacturer side. Some systems, like the buffer station, there are some things that it makes sense that you're making an investment, have a more smoother process flow, and be able to meet your throughput needs. And another example of that would be offloading a line. So it's the exact same concept as the elevatory buffer station, but offloading a line, what it would mean is basically like you have the two conveyors right here, right? This conveyor goes down and all the upstream devices are down right now. So what would happen is essentially you'd have a robot pick up the part and stack it, right? And so the robot would pick, stack, and it would stack until it basically says either I can't stack anymore, you gave me too much product, or you would have the ability to take a skid off, and then a fork truck driver could put another skid in place, keep that production running. Now, why would you want to do something like that? The reason why is because you want to keep up with your customers' demands. And also, another thing that I've seen is it is very, very smart to have automation where you go from the start as a raw product and the end is the end customer product, right? Whenever you design systems like that, they're generally very, very efficient But the one downfall to them is that if the upstream system goes down, then it takes down the entire line, which can cause some major issues, because it can especially cause some issues because it's not always the same process that goes down, right? So maybe it's the back end of the line, maybe it's the front end of the line, maybe it's the middle of the line. There's all these different parts of the line that can go down, right? Now you're essentially experiencing downtime from all these different areas of the system. Now, if it's just the back of the line that's always going down, it's always one area, then you can just focus on whatever that area is and get that, whatever the issue is there, fixed, right? But if you have downtime in the middle and the front and the back and all different areas of the process, right, then it's good to segregate the processes and be able to do like an offloading system where you have a robot that basically just stacks them, or an elevatory buffer station. The one thing that's really, really nice about the robot one is that you can just take racks off. So there's 101% operations where basically a robot will off stack, it won't pass product down to the end line, then a fork truck driver can take that off, robot stacks more, skids full, fork truck driver takes it off, boom, 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 right? Now we've taken off 50 pallets of full product that we couldn't pass downstream because the downstream is currently not functioning at the moment. So this gives you like a very good use case for allocating your employees. So you ran the front side of your line. So now you have all this product made from the front side of your line, and maybe it's a Saturday and a Sunday you have to have your guys come in and work, but instead of having your people come in and work Saturday and Sunday for the entire line, you can now take those same people that were working on the front side of the line, have them work the back side of the line, and have that fork truck driver reintroduce the parts back into the system. So now a fork truck driver is taking full parts, bringing them to the robot cell. The robot's then unstacking the products and passing it off to the second half of the station. So I'm only taking you guys through all these different scenarios and these different concepts of systems to kind of get your brains turning and really try to provide some value, because you have to really explain some of these things and make it so that people like understand the thought process and what really goes into different manufacturing processes. And maybe this is being done in automotive glass, but it's not being done in some other sector of the industry where it would be super valuable to have that exact same type of process. You can take a lot of things from, like, say for instance, the automotive industry, because their throughput is higher, they have more demands to meet, so they have a lot of really, really good things. A lot of investment has went into the manufacture or the automotive sector. So a lot of those things can apply towards other manufacturing sectors that don't necessarily have as much investment and don't have as much capital and budget to deploy into the development of new technologies and new automation. So that's where it's super advantageous. It's super good to spread the knowledge, educate yourself, and hopefully that we're providing that type of value here and you're learning something from watching these videos. If there's anything else you'd like to learn on automation and robotics, put it down in the comments below. We have a bunch of other stuff revolved around career, automating manufacturing facilities, ROI, like anything and everything automation and manufacturing related. We're here to talk about it. Put in the comments below. What do you want to hear about? Catch y'all in the next one. Peace.